Okay, lesson 13, multi-tenant architecture and RAC. In this lesson, we will go over standard architecture of Oracle database, and then we will take a look at multi-tenant architecture. And what about a RAC? So multi-tenant architecture in RAC environment. So we will cover this kind of topics. And here are the objectives. We will learn multi-tenant architecture in non-RAC environment and also in RAC environment. It's essentially same, but this architecture presents to more than one instances. That's the only difference when you manage a multi-tenant database in RAC environment. That's what we're going to learn. And also how to create multi-tenant architecture database. So that is called CDB, container database. And how to create pluggable database. And how to use default CDB and PDB services. So in order to access to CDB database and PDB database, and we use a service assigned to CDB and PDB, so we will use a default service to connect to CDB and PDB database. And we will also create dynamic service to connect to Oracle database, and it allows us to auto-start PDB at instance startup time. Okay, so we're going to discuss that topic as well. And finally, we will learn how to drop PDB database from RAC CDB. So let's take a look at non-CDB architecture. It used to be a standard architecture, and standard architecture consists of instance and database. And instance is memory structure and background processes. In the compute node, we start instance as the access point to Oracle database. And in the local storage or shared storage, we save physical structure of Oracle database. And with this architecture, we had some of the challenges. If you have multiple non-CDB architecture databases in the single server, we may have some memory overhead, and also we may have some CPU overhead, because each instance requires memory allocation regardless of each database activity status. And also, each instance requires some memory overhead to start background processes, let's say 50 background processes per each instance. So if you consolidate 50 databases into a single powerful server, you will have to expect 50 multiplied by 50 instances. So you have to have a memory space to start those background processes. And also you have to start 50 set of instances in the compute node. That's memory, waste of memory. And also, in the storage area, if you have 50 databases in the single box, then you will have a 50 data dictionary set across 50 databases. So that's also duplicated data. So that will consume a little bit of a space. Okay, so I'm going to give you one simple diagram to give you this example here. When you look at a non-standard architecture, the non-CDB architecture database structure, and you see in an SP file, that is one of a component, and we use SP file to start database no mount state. And also, we use a control file to start database up to mount state. And to open database, we need an online redo and we need a data file. So that is your non-CDB database architecture. And we use a single instance to access to physical structure. So that is an example of a single instance database. Now, with this architecture, suppose that I want to consolidate 6 databases into single physical server, the single database server. Okay, so if that is the case, we have to start we have to start background processes of a first instance, the background process of a second instance, third instance, all the way up to 6th instance. And also, we have to allocate SGA memory space for first instance, second instance, third instance, all the way to the end. And also, we have a same set of structures across in 6 databases. what if, in your environment you have this kind of this kind of action observation. We have some of the database running actively at given time, and some of the databases are running with a very minimal workload. So not all database instances are active, and we want to consolidate. We want to actually consolidate all these databases into single database server. When using this, this architecture, regardless of a database activity status, anyway, we have to start database instances, whether it is idle instance or active instance, doesn't matter. So we need this amount of actual memory space, and also we have to keep same set of data dictionaries. Okay, so in order to improve this database structure in terms of resource management, Oracle also introduced this architecture, multi-tenant architecture. So when you look at multi-tenant architecture, physical structure, it's about same. SP file to start database, no mount to state, and control file to mount to your database. And to open your database, we need an online redo log file. And we have containers. Wait a minute, what is a container? The container is nothing more than a set of table spaces, or you can say a set of data files. And it is another management unit. So it's possible to group set of table spaces for each tenant with this architecture. Okay? If you want to convert single instance database with a non-CDB architecture to CDB architecture without applying database consolidation, yes, we can do one-to-one mapping. So just like this example, I don't want to use this architecture for consolidation, but for the future plan and for future project, I want to convert non-CDB to CDB architecture. So in this case, you keep same instance, you keep same control file, you keep same online redo, and you keep set of data files. So system table space, sysoc table space, undo table space, temporary table space. And then we group them one as a root container because we keep all the system-related information in this group. And also, we create seed container to keep template files. And then you create another container to keep application data. So we only separated and we only grouped table spaces, okay, by content. So that's it. So I don't see much difference, okay, other than grouping table spaces. That's it. Now, why this architecture is very useful? Now, if you really want to apply database level consolidation, because as we saw, with a server level consolidation, regardless of your database, workload pattern or activity status, we had to start same set of resources. But with this architecture, look at this. Suppose that I was able to group 3 non-CDB databases because those are databases with the same requirement and same availability, same performance requirement. So, we can group all 3 databases as a pluggable databases, but we start only one instance. And when you configure this instance, we only allocate large enough memory to be able to support the active workload or active database. Instead of allocating the instance that used to be used by 3 databases. And also in the second, the consolidation, same thing. So we group another set of 3 databases. And also we allocate only large enough memory space. So you can just go with one-to-one, so one non-CDB architecture, and then you convert it to CDB architecture, so one-to-one mapping, or many-to-one. So if you have a multiple standard architecture databases, and you could convert it to the multi-tenant architecture database as a part of a database consolidation. So what is the benefit? Since I can only optimally allocate instance to support active databases and active workload, I can reduce memory overhead or instance overhead. And also all these databases share same data dictionary. So we can only keep single copy of a data dictionary, so we can save a little bit of space. Same thing in this area. So this is actually a benefit of a multi-tenant architecture. And also, we can actually run this multi-tenant architecture across multiple instances as well. So we make in a physical structure, the physical structure visible to multiple instances. So that's a multi-tenant architecture in RAC environment. Okay, if you present your physical structure only to single instance, that's a single instance database. If the same structure available across instances, that's your RAC database. Okay, so this is actually an example of a multi-tenant architecture. So let's take a look at this now. So as you can see, we have a less instance overhead and less the storage cost, and it reduces DBA resource cost and also it maintains security. And since we're gonna make connection to a pluggable database in the multi-tenant architecture with the same service, so there is no application changes. And also in the multi-tenant architecture consists of regular PDBs and also seed container. And that is a template, and we can use it to create empty PDB database. So we can actually use it for the faster provisioning. Or you can clone the new PDB out of existing PDB. So my terminology here, pluggable database is nothing more than containers, okay? But there is one container that cannot be pluggable database. That is a root container. So root container is a core component of multi-tenant database. So we're not going to call root container as a root pluggable database. But other other containers, we call it as a pluggable databases. And also time saving for patching and upgrading, because in this example, suppose that we do have in this case 12.2 database, and this is 12.1 database, and application 1 recently certified with a 12.2, for example. So I want to upgrade database to 12.2. So in order to upgrade this database to support application and to let application take advantage of new features, you can actually upgrade the entire CDB database. Now, if that is the case, that will affect APP02 and APP03. And these application databases are not certified with the 12.2. Then that's going to be a problem. That's why what we can do, we can unplug APP01 from CDB database, and you can also plug into 12.2 CDB database. And you have to execute a few set of scripts to synchronize with a new database, but it's just simpler patching and simpler upgrade. So this process is possible with this architecture. So patching is easy and simpler, and upgrade process is easy and simpler from PDB perspective. And also PDB is nothing more than set of table spaces. It's kind of a transportable table space concept. You can just unplug and plug into another database. And also we can create different set of users. So we can make one user account to manage entire CDB architecture. And we can also create PDB admin to manage only specific pluggable databases. And also, each PDB database is isolated. and also CDB in non-RAC environment. So it's a multi-tenant architecture can be presented to single instance or multiple instances. So if this structure is presented to single instance, that's a single instance multi-tenant architecture database. So CDB is multi-tenant architecture database. Okay. So containers. There are two types of containers. One is one is root container. It is mandatory. It stores all Oracle system supplied common objects and also metadata and common users like a sys user and also roles, predefined roles. And also we have pluggable databases. You can plug up to 4,000, little over 4,000 pluggable databases. And the service limit, we can add up to 10,000 services. So if you want to look at the containers in your environment, you can use this in Fidela view. So this is in my environment. And what I can do, I will log in as a sysdba. And you can actually select container ID and name from Fidela containers. So as you can see, we have a root container named CDB $root, and also seed container named PDB $seed, and also PDB database. And then we have each assigned the container unique ID, 1, 2, 3. So we have an ID assigned in this way. Or if you want to display only PDBs, you can type show PDBs. As you can see, we do have PDB $seed here, and also PDB1, but it doesn't include the root container. So that's what we can see. And we also have a terminology. So now we have the different levels of management available. So we as administrator, we should be able to manage entire CDB. So we have a CDB level management. And also if you are a pluggable database admin, you should be able to manage only pluggable database. So you need in a PDBA. And also you can actually manage a set of pluggable databases as well, just like a DBA. So we have a different views available, DBA view and CDBA view and PDBA view to see a different set of information. And we also have a terminology common and local. So there is a concept called common user and common role and local user and local role. The local user and local roles is nothing more than the roles that are granted to specific users within specific PDB. And also users exist in specific PDB. That is a local user and local role. And also common means users and roles available across PDBs. Okay? Typically, admin user account must be available across PDBs. So that way, I as admin account, I can access to not only root container, but also other PDBs. Okay? So example. So let's make this example. So what I'm going to do here is I'm going to I'm going to log in as sysdba. Okay. So who am I? Show user. I'm sys user. And this is an admin user, and this is a common user. Why this is a common user? Because I can also log in to PDB1 as a sysdba. Oops. PDB1 connect identifier. Oh, I didn't actually update TNS name entry, so I will have to provide a full alias, net service, alias information. Host 01, 1521, PDB1, Edge sysdba. So Edge sysdba, I'm also able to log in to PDB1. So I can type show con name. I'm in the PDB1, show user. As the same user, I was able to log in to PDB1. So this kind of a user is called common user. But this is system supplied, an Oracle supplied user. Now, can I create user-defined common user? Because when you consolidate databases, you should have some requirement. Okay, so I want to actually consolidate databases based on same backup requirement or same security requirement. So you should have your own requirement. So let's say I'm going to actually create security user, assuming that we consolidated the databases with the same security the requirement. So what I'm going to do, I'm going to create user called SEC, and then identified by Oracle underscore for you. So can I create this user in this way? No, I cannot. So what is the reason? The reason is I have to create this user and I have to make it available across PDBs. Okay? To do so, you have to check requirement, show parameter, comment. So as you can see, the common user must include the C ## prefix. So you have to create user C ## and security user count identified by Oracle underscore for you. By doing so, I can create. Okay, so now this is a common user. Can I log in as this user to a PDB? So let me try. Connect C ## security user and Oracle underscore for you at host 01 1521 and PDB1, enter. So as you can see, I don't have a privilege. So even though I created a user account, it's not enough. So you have to grant enough privileges. So just to make it simple, I'm going to grant DBA role to C ## security. Or I can use a better option, sys key manager to C ## security. So I granted. So this time, can I log in? So let me test. So I'm not able to log in. So granting sys key manager to C ## didn't work. So let me say, just like message here, I'm going to grant create session explicitly to see if that works. Grant create session to C ## security user. I was able to grant. I'm going to connect. I still have a problem. So even though I granted the sys key manager or create session privilege explicitly, I'm not able to log in as the same user account to PDB1. What happens? It is because when we granted the privilege, we only granted the privilege to user in the root container, meaning that that's a local privilege exercise. So if you want to grant the same privilege to the same user across PDBs, then you have to use it in a different way. You log in as sysdba, you have to grant create session to C ## security, and container equals to all. So you have to apply this exercise across all PDBs. Then what? Can I log in? Here we go. That is a common privilege exercise. So as you can see, in the multi-tenant architecture database environment, you can grant privilege locally or commonly. You can create common user, and you can also create local user as well. So can I create a local user here? So where I am. So I'm in the PDB1, so container ID 3, or container name, the PDB1. And then what I'm going to do, I'm going to create new user, create user. So can I create C ## ABC user, identified Oracle _ for you? Can I do this? No, invalid. Why? C ## only applicable to common user. Common user must be created in the root container. So in this location, you have to create private user without C ##. So like a Sean identified by Oracle _ for you. So I don't have enough privilege, but with the enough privileges, you can actually create user like this. So if you want to see connect sys Oracle _ for you at host 01 1521 PDB1 at sysdba. Since I didn't grant enough privileges to C ## secure user, I wasn't able to create user. So I can create user as a sys user account. So that's what we can see here. So we have a different data dictionary information. So we have a user view, all views, and DBA views, and CDB. CDB view can display all objects in the multi-tenant container database across all PDBs, but user view only show you objects owned by current user account. So you can actually test with this method. Select table name from dictionary where table name like CDB and also DBA or all and user. So you add a keyword to display all CDB views, all DBA views, all user views, and so on. And how to connect to CDB database. The way to connect to CDB database is using service. So we can use a service. So for example, let's take a look at listener status. So I have actually various entries here, especially we have this. This service is a default service to CDB database, and this service is to connect to instance named CDB1 _ 3, eventually to access to root container. And this is a service name, and this is to connect to CDB1 3, and this is to connect to pluggable database named PDB1. So whenever you create pluggable database, the service with the same PDB name will be created. So we use this service to connect to your environment. So for example, I'm going to use SQL plus sys Oracle _ for you at host 01 1521, and then I can use /CDB1, for example, as a sysdba. So in this case, I provided a service name, same as your database name. In this case, we log in to root container, main component. Or if you just replace CDB1 with the PDB1, then you can actually log into PDB with the same name. So we use a service to log in to containers. But what about this? Connect as a sysdba. Okay, so I can do this way as well. It's an OS authentication method. So in this way, I'm able to connect to a root container. Now, there is another way to log into PDB or other containers. So my current user is a sys user. Okay, can I log into PDB1 as the same user count? Yes. Alter session set container equals to PDB1. So I can just switch container with the same user count, show user. So it's only available if you are connected to container as a common user. So like this method, okay? So I will just use connect as a sysdba, okay? So I can do this way. And let's make this scenario. I create table name like ABC, and column and number. Oops. Okay, so I will disable key repeating. So I created a simple table and insert into ABC value 1 values 1 and then another row. So I'm adding actually multiple rows. I didn't commit yet. Before the commit, if I issue DDL statement, what will happen? Okay, so I switched session. Actually, I switched the container to PDB1. So since it is DDL statement, you may think so previous the uncommitted transaction is committed. But is it true? Let me actually convert it back. CDB $root. And I'm going to type rollback. And then select star from ABC, nothing. So which means that alter session command is an exception. Even though it is a DDL statement, it will not commit previous uncommitted transactions. Okay, so that's another thing what you have to understand. So we have various examples here. So we can make local connection. We can make remote connections as well. And also I showed you this method, connect as a sysdba, connect local at PDB dap. So you can also make connection remotely. And also at the same user count, you can easily change a container. And also alter session set container allows connection only under common user. So that's what I mentioned. And alter login, after login triggers do not fire. Transactions are still pending after switching containers. Okay? So far, I briefly introduced multi-tenant architecture. And this multi-tenant architecture can be presented to only single instance. That's a single instance database. We can also present same architecture across instances. That's a RAC environment. So when you look at this example, we have a multi-tenant database. So in the single instance, your CDB, in this case, which one is it? CDB is presented to single instance, okay, here. And also this is a non-CDB database presented to single instance. So this is an example of single instance database. And also, this is a non-CDB database. It is presented to all three instances. It is a RAC database configuration with a non-CDB. Now in this case, my underlying structure is a multi-tenant architecture, and this architecture is presented to all instances. That is an example of multi-tenant architecture in RAC environment. So just like in a standalone environment, you can a non-CDB database, you can make it as a single instance database, you can make it as a RAC database. When you configure a multi-tenant database as a RAC database, or when you present multi-tenant architecture across multiple instances in RAC environment, are we going to see any difference between non-CDB architecture in RAC, multi-tenant architecture in RAC? No, it's essentially same. So look at this. These are all what we learned. Several instances per CDB. And in shared undo, only one undo table space per CDB instance. That's what we learned. In local undo mode, every container in the CDB uses local undo table space. Same. Actually, this is only multi-tenant architecture. And list 2 groups of read log files per CDB instance. Same. And each container is exposed as a service. So you can use a service to make connection to container. And you can also create the policy managed database. And I showed you default database services. In addition, you can also create policy managed non-default, which is called the dynamic database service as well. How to create RAC database CDB? Okay, so you start DBCA, and then you you choose a policy managed configuration type, and then you create server pool if there is no existing server pools, and you also add the cardinality. So I will add 3 servers as a maximum. And also, what is my database name? And this is an option. I want to create my database as a container database, and I'm going to use a local undo table space, and I'm going to use one PDB database in one CDB. Okay, so you can create a multi-tenant architecture with a single the tenant, which is called the PDB1. Once you create database, your database can be presented to multiple instances. In this case, CDB 21, 22, 23. And also, you can check undo table space and also redo. And observation will be same as standard architecture, which is a non-CDB architecture. And you can connect to CDB and PDB database by using service. So in this case, host 01 and port number 1521 is default. And then we provide the service name to connect to root container. And also you can connect to the PDB2 by providing service name. So we can make remote connection by providing service information. So you will have to check listener whether listener understand these services. So by doing so, we can make connection. Now, another thing what we're going to see is opening a PDB in a RAC CDB. So let me actually give you this example. Exit out. SRVCTL status database -db ORCL verbose. So let's take a look at this. Oh, it's not ORCL, it's just CDB1 in this environment. Okay, so as you can see, we have 3 instances, and there is one non-default service. Okay, what I'm gonna do, I'm gonna drop this service on purpose. So I want to stop first and then remove. And then I will check my database in a status again. Okay, so there is no non-default service at this point. So what I'm going to do, SRVCTL stop database -db or cdb1. I'm stopping database. So what I'm going to do is I will start this database, and then we're going to check status of containers. So it takes a little bit of time to stop database across all 3 instances, and I'm going to restart. So it takes a little bit of time. So meanwhile, I can also check alert information as well. So instance shutdown. Okay, so I'm going to start now. So it's in progress now. Something going on in the background. CDB instance recovery complete, and also there are lots of things going on. So it's just still running, but here it's done. So what I'm going to do now, I'm going to check instance name in the current server. CDB1. Purpose. In host 01, the instance name is cdb1 _3. Okay, same. And I will log in as sysdba and show PDBs. Look at this. And even though I started the database instance, my PDB1 is still mount state. Okay. What about containers? So let me see. I have open time. I have open mode. So let's take a look at this. Select container ID, name, open mode from $containers. I will just format it. So as you can see, even though root container is open, read, write, seed container is read only, but PDB is a mount state. So it doesn't start instance the PDB automatically. So what I'm going to do is I will use alter pluggable database PDB1 open. So I will make this available here. And then I'm gonna issue show PDBs. So as you can see, it is a read write. So what I'm gonna do, connect sys oracle _ for you at host 01 1521 PDB1 at the sysdba. So I'm able to connect to PDB1. The question is, can I connect to second instance that is running on host 02? So I can also, in this case, connect. And also, you can check third instance. You can connect. So as you can see, you can make connection in this way. But instead of starting PDB1 in this way, you can also start PDB1 selectively. For example, alter pluggable database PDB1. I'm going to close this, but only through one of the instances, CDB1 _ 3. So meaning that my PDB is still available across two instances, but not through this instance. So what I'm going to do here, so when you type show PDBs, look at this. So my current instance location is closed because I made this PDB1 invisible to this. So when I try here, this command, this is connected. Just this. I think this is not actually on mount of it's because of a sys user. It's still mounted to the state. So if you want to actually start this again, you have to use open. And if you want to make it available across all instances, you have to use instance close. So that way, we're going to make this PDB1 available one or more or all of instances. So that's the description of this slide. Open and instances and open all. And you can also close CDB, but also you can close the PDB data file headers to make PDB not available. And also you can close PDB only to specific instance, or you close this PDB across all of instances. You can also relocate it as well. So by doing so, you can control availability of a PDB in this way. And also we learned services available, just like a non-CDB environment. And there are two types of services. One is sys background, and the other one is sys users. And sys background is to group background process connections. Sys users is to group the local connections. In addition, we can create non-default services in addition to default services. So we have internal services and also default services to CDB and PDB. And you can also create up to 10,000 services per CDB. And so there are two categories of services to manage. One is the default service, that's what we saw. And default service is not managed by Oracle Clusterware. So that's why the time when you start Oracle CDB database instance, Clusterware doesn't check status of PDB database. However, when you create non-default service, when you create non-default service, this service will be managed by Oracle Clusterware automatically. So Clusterware will attempt to start non-default service, but to do so, database must be available as a requirement. So before starting service, Clusterware always start PDB first to be able to start service, meaning that at CDB instance time, Clusterware automatically start PDB to start non-default PDB service. So this is a way to start PDB automatically at CDB instance startup time. So that is the one option. So we can actually use this method. So I'm going to show you this. So what we're going to do here is srvctl add, and I'm going to add the service to CDB1 database. And service name, and I will just use test. And server pool and ORCLDB. Let me see actually what is the server pool name in this environment. srvctl config database -db cdb1. Let me check which server pool is used. CDB1 pool. So that's CDB1 pool. srvctl add service -db ORCL CDB1 and service name test server pool, and this is server pool, and I'm going to use a cardinality uniform. So I will start this service across all instances of across all database instances. And then I will hit enter. And then I'm going to start this service. And then let me check service status from CDB1 database. Okay, so as you can see, non-default service showed up in this output. So test service is available across all 3 instances. So what we want to do here is, let me actually stop database. I'm going to stop now. I can check alert. The thing what I want to show you here is I stop the instance. When I start instance, does Oracle make PDB available automatically? But previous in our demonstration, at instance startup time, PDB was in mount state. That's why I had to start PDB manually. But what about with non-default service? So I created a non-default service. We assuming that clusterware will take care of a service. So to start service, PDB will be auto started to be able to make service online. Okay, that's our assumption. So I'm going to actually start now. And I want to check alert. Okay, so let's come back. Something going on. Okay. Let's see here. So now this is done. So I'm going to actually check service status again. Okay, service came back. So I'm going to log in as a sysdba and show PDBs. Why this is just still mount state? So did I miss something? I expected open state. Oh, I know actually there is a reason. So this is my bad. What I had to do was I missed the PDB name. I had to make this as the resource of a PDB. I forgot to add the service name here. So what I'm going to do, I will slightly change it here. Dash PDB and PDB1. And I will change the service name. Oops. So I will do 01. That's my bad. I missed in PDB. So I'm going to start service. Service name 01. And then I'm gonna stop and restart. And this time, stop option. Let's say abort. And then I'm gonna simply start. So I had to associate service with the PDB. So that way we could open PDB1. But previously I created a non-default CDB service, not PDB service. So that was my the small mistake. So I just made a correction, and let's see how it goes now. Okay, so let me log in. Look at this. After I associated a service with a PDB, as you can see, at instance startup time, PDB automatically opened in this way. So this was an example of this affinitizing PDB services to server pool. And also adding PDB to a RAC CDB, if you want to create new PDBs, there are many different options. The first option here is you can create PDB from CDB. The CDB is a template, and template is used to create empty PDB database. So for example, you have a previous version of a database. You are about to migrate this database. So you create empty database, and then you can export from the source database and import into new PDB database. So you can use that. You can use the first option. The second one is if you want to create a development environment or testing database out of an existing PDB, you can use create pluggable database from PDB1. So by doing so, you can create copy of a PDB. And also default PDB service is automatically created and automatically started for newly created PDB. Finally, if you don't need a PDB, then you can remove all dependent resources like a dynamic PDB service, and you close PDB across all instances, and finally you can drop it. Okay, this is dropping a PDB from RAC CDB. Okay, here we have a quiz. Which of the following are true? Only one system table space per CDB. No. So system table space exists in each container to describe objects in each container. And only one instance per PDB. No, it's a CDB level. A set of a read log file per PDB. No, it's a CDB level. Only one undo table space per CDB instance. Yes, so we have only one undo table space assigned to each instance. Actually, there are different contexts. If you, whether it is a shared undo concept or local undo concept. If this is in a shared undo, then the answer is yes. If this is a local undo, then you can have more than one undo table spaces per CDB because we create undo table space at the PDB level. Okay, so statement D, it could be yes or no depending on the context. And statement E, one sysocs table space per PDB. Yes, we create one sysocs table space per PDB, and also there is a sysocs table space in the root container as well. And this is a lesson 13.